Okay, this is part 2 for lesson 7. Before we get started on this video, I want you to go down near the bottom where there's this graph and then these 4 right here. What you're going to do is you're just going to cross this out because we're not going to do that part. So you do not need to do that part. Okay, and we already read number 3 in the last video, so we're going to go to number 4 over here. If you turn your paper like this, there's number 4 right here. So 3 out of 5's done. It's fun to rhyme it. Here's 2 more factors that affect the climate. High in the sky where the cold wind blows, across North America the jet stream flows. Most weather moves from west to east because it's blown right along by the jet stream breeze. But it's not a straight line, and it moves around. And sometimes it carries really cold air down. Big storm you can get the jet streams behind it, going over your head to affect the climate. Jet stream sweeps from west to east, said the jet stream sweeps from west to east. All right, so we're going to use that information to help us fill out this part right here. Now, the jet stream moves in kind of like a curved path. So it moves from west to east, and the jet stream kind of moves in this curved path like this sometimes. Sometimes it travels in a curved path like that. And it's always from west to east. Always. Okay, so this is the jet stream, but also this is the jet stream as well. Okay. Now a jet stream travels across the United States. A jet stream travels across the United States. It can bring cold air down from Canada and warm air up from Mexico. So if you see the pattern, right? If it's coming down like that, this area, that means it's going to be cold air from up here is coming down. But then if it's flowing like it goes down like this and then comes up, that means that this air it's going to come from Mexico and bring it up like that. Okay? This is why sometimes you can get like cold areas down here during the winter. You can get like cold fronts because it comes down from here. Sometimes you can get like really weird hot temperatures up here because it will come up from Mexico. Okay. All right, and you'll see you're going to use your blue and red again. Use your blue and red. Because warm air travels toward the poles and cold air moves toward the equator. This movement creates convection cells. So if I take my blue, looking at this map, we have the equator in the middle. This is our equator. This is our North Pole and our South Pole. The red is going to move away from the equator towards the poles. So the arrows that go from the pole up towards the north are going to be red. Okay, and then these arrows that are pointing down towards the South Pole, those are also going to be red. Because as it's moving away from the equator, it's warm air being carried. Now, if the arrows are going down towards the equator from the poles, it's cold air moving down, it's going to be blue. You could probably color them a little bit neater than I am right now, but I'm just going to kind of scribble it in because I don't want this video to be too long. Okay. And the last thing that I want you to remember about global winds is that the jet stream sweeps from west to east. The jet stream sweeps from west to east, so it goes from California all the way across the United States to the east coast. Okay. All right, so the last part of this is proximity to water. Just as a reminder, you do not have to do the graph or these little, just cross those two things out. So the proximity to water. Okay, the rap says, when the sun beats down, all the rocks get hot, but to heat up an ocean takes an awful lot. Temperature is moderated by a body of water. You got it. It flattens out the pattern if you plot it. Climate on the coast stays relatively mild, but move inland. Fluctuations get wild. Big lakes put on the brakes slow. Big lakes put on the brakes slow down changes, but landlocked areas see very wide ranges. Farther from the water, colder and hotter. Farther from the water, colder and hotter. Play it on repeat until you can rhyme it. Now you know the factors that affect the climate. So, what this is saying is that land heats up and cools down faster than water. So in a coastal region, so this is like close to an ocean or a big, big, big body of water. Coastal, mild climate. This is mild climate. That means there's maybe a 20-degree difference. So this is kind of like San Diego. Example would be San Diego. This is, so like if you go to California, in the winter and the summer months, they're about the same temperature, right near the ocean, because that ocean air kind of keeps the same temperature all year round. It does not heat up and cool down very fast, so it stays kind of in the middle. But if you live inland, you're going to have more of an extreme climate. Okay? You're going to have an extreme climate. And that means you're going to have maybe, oh my gosh, I keep making mistakes, maybe a 90-degree difference. So this is like Tremonton. So we are not close to an ocean. So we are inland, and that means our climate is extreme. We have super cold winters and really hot summers. And because the land will heat up and cool down really fast throughout the year. So it can get really, really hot or it can get really, really cold. There's no ocean to help balance that temperature out. Okay? So the key point here is down at the very bottom, this last part I'm going to have you fill out. The farther from the water, it's colder and hotter. So it gets really cold and really hot the farther you are from water. So once you fill all this out, you are going to turn it into the bin and move on to the mastery check.